Hello all, today we are covering the third part of 4.5, solving quadratics. Before we get into that though, we are going to discuss how to solve imaginary and complex numbers by adding, subtracting, multiplying, and dividing. So first of all, we need to know what an imaginary or complex number is. An imaginary number is a number from the square root of -1. It's derived from this. The square root of -1 is equivalent to I. This is because to find the answers to square roots, we just think about what times what itself equals what's in the square root. The thing is, nothing times itself can equal a negative. 1 times 1 equals positive 1, and negative times 1 times -1 equals positive 1 as well. So the square root of a -1 is equal to the imaginary number I. Therefore, I squared is equal to -1 if we just work backwards. So we can think about these, it's kind of a repeating pattern. If you have just one I, that's the imaginary number I. If you have two i's multiplied, or I squared, that is equal to -1. 3 i's multiplied, that is equal to -I. 4 i's multiplied is equivalent to positive 1. And then you repeat. I to the 5th would be just I. So it's a repeating pattern there. We will mostly just use these first few plus this idea, but it's good to know everything. We also have the standard form of a complex number, which is written as A plus BI, where BI is the imaginary part and A is the real part. Now, you can think of I when solving as if it is a variable, but I is not actually a variable. I is equivalent to the square root of -1. So it does have an association of a number with it, unlike, say, the variable x, which you have to figure out what it means. So when we come down here and we work on adding, subtracting complex numbers, you can sort of treat it like a variable, like I, 1i and -4i are like terms, and 5 and 8 are like terms, but don't solve for I separate. So you just combine like terms. 8 plus 5 is 13. 1i minus 4i is -3i. Notice we always try to put our real part out front and our imaginary part following for our standard form. So simple enough there. It does change a little bit when we subtract. We need to take our subtraction here and change it to a positive. If we do that, it's like distributing a -1 through to each of these other two terms. We have to change or add the opposite, I guess you could say. So if we add, then we take the opposite of each term, then find your like terms, 7 and -3. And -6i and 6i. Notice 7 minus 3 is 4, but when you take -6i plus 6i, you end up getting 0, so you already have your subtracted complex number, which is just a real number solution. Multiplying complex numbers gets a little trickier, although it's not too bad, especially if we have it in this sort of form, where we're just doing single distribution. So we go ahead and distribute 4i to both pieces. We take 4i, I'm going to write out a bunch of extra things. We take 4i times negative 6, and then we add 4i times I. Now, eventually you'll get into the habit of not having to write all this stuff out. You'll be able to do this step in your head. But for now, I'll write it all out to help you out. So on this first part, 4i times negative 6, you just multiply the numbers and you get negative 24i. On the second part, it works sort of like an x. If you had 4x times x, you would get 4x squared. So this works similarly. You get 4i squared. Now if you recall from up here, I squared is equivalent to negative 1. So we want to plug negative 1 in here. So we will have negative 24i plus 4 times negative 1. We go ahead and multiply, so 4 times negative 1 is negative 4. And then, as I said before, you want to put your real part first, so you just switch them around. So negative 4 minus 24i is our multiplication of our complex numbers. I'm going to flip over to another page and do another one similar to that. So I'm creating this new note. We're going to do one similar. We're going to take 3i times negative 5 plus 2i, go from here. So we distribute this through, we get negative 15i plus 6i squared. So I did that first part in my head this time. Took 3i times negative 5, got negative 15i. I took 3i times 2i and got 6i squared. I know I squared is equivalent to negative 1, so I need to take 6 times negative 1. And then I need to flip the order I put them in so that my real number is first, and I'm done. So now, since we've tried 2 of those, we're going to move on to a slightly more complex multiplication of complex numbers using our FOIL. So if you don't recall FOIL, we haven't practiced this too much. It's first, outside, inside, and then last. So we take our first 2 terms multiplied. This could also be called double distribution, where you take the first term in the first parenthesis multiplied by the other set of parenthesis terms, and then the second term multiplied by both. That's your double distribution. Or you have that first, outer, inner, last multiplication. This one, once again, I will show out all the steps just so you can see them. So 3 times 5 plus 3 times negative I plus I times 5 plus I times negative I. Kind of ran out of space. Let me move some things around. All right, there we go. So now you just multiply within each choice. So 3 times 5 minus 3i plus 5i minus I squared. We end up getting, well, first of all, we know I squared is, as you see up here, -1. So if you see minus a negative, that becomes a positive. So we have 2I plus 16. Okay? All right, we're going to try another one of these once again on the other page, and then we will move on to something different, but yet similar. Okay. So we are going to take similar type problem, 4 plus 3I times -1 minus 2I. Double distribute, so first times first, outside times outside, insides, and then last. I'm going to do this part in my head. First, outsides, insides, last. I know that becomes -6. Combine the rest of my like terms. I missed a sign, didn't I? This is a +3. There we go. Whoop, whoop. Switch some signs. There we go. All right, now we're on the right track. So I squared is negative, so that becomes a +6. Here we go. Finish combining like terms, so we get 2 minus 11I is our solution. Sorry about that sign mishap. All right, so that is double distributing. That is those ways that we can do this. There is one other thing I want to cover. That is called the complex conjugate. So if we scroll down, I have a definition for you. We have a plus bi and a minus bi are complex conjugates. The product of these is a real number. Okay? So we don't have any examples of these on our notes, but we're going to do some here. We are going to take 9 plus 12i over 3i. Similarly to not wanting radicals left in the denominator, we also don't want imaginaries in the denominator. So we can take our complex conjugate. Notice the only difference between these is that their middle sign changes. Right now we have 0 plus 3i. That means we're going to change it to minus 3i and multiply both the numerator and the denominator. This guy's equivalent to 1, so we're keeping everything the same. It's just going to look different. And we're going to multiply both the numerator and the denominator by this. So when we do that, we're going to have negative 3i and then 9 plus 12i over 3i times 3i, negative 3i, excuse me. So we'll have to distribute here. We get negative 27i minus 36i squared. We know that 36i squared becomes 36 times -1, or 36 minus 27i. And then we know that 3i times negative 3i is negative 9i squared, which then just becomes positive 9. Now, if you recall from a couple days ago, I told you if these can be divided, go ahead and divide them. They all have to be divisible by the same number, though. In this case, they are divisible by 9, so each of these gets divided by 9. Oops. And we ended up getting 4 minus 3i is actually equivalent to this guy up here, but looks much nicer. That's using our complex conjugate, just multiplying the numerator and the denominator by the opposite sign of what's currently in the denominator. We can do the same thing with a slightly harder problem. We have 2 plus 3i over 1 minus 4i. We can multiply both the numerator and denominator by the complex conjugate. That's just switching the sign that's in front of the complex term, the imaginary term. So these become both positive versus both negative. Then we're going to have to double distribute. Remember, if you're multiplying complex conjugates, they become just a whole number as your solution. That's pretty nifty here. It'll be easier to see out. We double distribute. First, last, insides and outsides. I'm gonna just combine these all at the same time. So 2 plus 8i plus 3i minus 12. So I did my I all together. It was plus 12i squared, which just becomes minus 12. And then we'll end up combining like terms. I want to go ahead and double distribute down here. So first times first is 1, outsides is plus 4i, insides is minus 4i, and last is going to be minus 16i squared, which then I squared becomes negative 1, so we get plus 16. So you can notice in the denominator, 4i minus 4i goes away. Woohoo, we knew that was going to happen. Combine like terms in the numerator, negative 10 plus 11i, all over 17. Nothing can be reduced here, but you can split this out to be negative 10 over 17 plus 11 over 17i is your equivalent to our original. Now we're good to go. All right. So before we move on to our final idea, last three problems, we're going to talk about imaginary units and how we can simplify something such as the square root of negative 25. Now, as we did the other day, you can split this out. We can say that the square root of negative 25 is the square root of 1 and the square root of 25. That makes it seem pretty simple. We know the square root of 1 from way at the beginning on our other slide. The square root of negative 1 is equal to I. So simply stating, the square root of negative 1 is I, and the square root of 25 is 5. Now we usually write these as the number multiplied by I, so our solution is simply 5i. They can get slightly trickier though. We can have something like the square root of negative 18, where once again we can split this out into the negative 1 and the positive 18. Negative 1 goes to I, while 18 we can split out into its factor tree, circle its leaves, and do the 2 times 3 times 3. Highlight the buddy pairs, the buddy comes out, and then we have to remember, keep bringing down that I. Once again, usually it's 3i root 2. That is just how we write them in our math classes. Okay? So this guy is actually equivalent to this guy, believe it or not. You can go back and forth between them. And lastly, we can also have root -7. So you can split this out to -1 and 7. Notice 7 cannot be broken down any further, so you can only bring this to I, and then you have I root 7 as your solution. So let's get back to our other notes page, and we will finish it out. So if we are going to solve these quadratic equations, they look like similar ones to yesterday's. Because there is no just x value, you can solve them as if they were linear by subtracting 1 on both sides. Sorry, subtracting 11 on both sides. Go ahead and finish solving. We have a little bit of a problem here, but that's okay. We just learned how to deal with it. We have the square root of -24. We don't want to leave a negative inside of a radical, so we want to take -1, square root of -1, square root of 24. Go ahead and split 24 out, see if we can reduce it by anything. So it looks like we can. We do have one pair of 2's. So we have the square root of, and this I comes down here. We have the square root of 2 times 2 times 2 times 3. This 2 buddy pair comes out in front of the I. So we're left with 2I. Root 2 times 3 is 6, and we are good to go. Okay? And this is our solution. Maybe I should highlight it in a different color. All right. Oh, one thing to add. Let me actually move that down. When we do something like this, if you recall, quadratics have 2 solutions, so it's plus or minus 2I root 6 is equal to x. Gotta be careful about that. All right, now we'll move on to the next one. Notice these are both labeled 2. I'm going to call this one 3. The next one, we subtract 33 on both sides. So we have 5x squared is equal to -30. Divide by 5, divide by 5. Notice you're going to have x squared equal to a negative, which means when we take the square root, we end up getting x is equal to the square root of -6. We want to split that out into -1 and root 6. Root 6 can't be reduced any further, so we just have I root 6 is our solution. Once again, notice we need plus or minus I root 6 equals x to be completely correct, because there are 2 solutions. Alrighty, and then lastly, this type is a little different. We covered one of these the other day. You want to start by dividing -3 on both sides. So we end up getting x plus 2 squared is equal to -3. Take the root of that, so x plus 2 is equal to root -3. If you want to, before you even move ahead, you can go ahead and say, well, this is root 1 and 3, which means it's I root 3. That's fine with me. That's just the simplification of that guy. Then subtract 2 on both sides. And we want to say -2 plus or minus I root 3 is equal to x. There's 2 solutions, -2 plus I root 3 and -2 minus I root 3. And we are good to go. All right, hopefully that helps you with tonight's Math Excel. Have a great afternoon.